In this question, we want to find number of linearly independent vectors in v1, v2, v3 and v4, and to do that we will use the matrix rank method where the given vectors form columns of our matrix. So the matrix will be v1 forms the first column, v2 forms the second column, v3 forms the third column and v4 forms the fourth column of our matrix. So our matrix will be 1 1 0 0 1 1 2 3 1 1 1 1. As we know that rank of a matrix is equals to number of linearly independent columns in that matrix, and because the columns of this matrix are our vectors, so rank of this matrix will be equal to number of linearly independent vectors in our vectors. Now because this is a big matrix of size 3 by 4, I will use the row echelon form to find rank of this matrix, and the number of pivot elements in the row echelon form of this matrix will be the rank of this matrix. And to get the row echelon form, I will use the row transformations. So I will start with R2 to R2 minus R1. So here R2 minus R1 will lead to subtraction of minus 1 here, minus 0, minus 2, minus 1. So this will give me 1, 0, 2, 1, 0, 1, 1, 0, 0, 1, 1, 1. Next, I will do R3 to R3 minus R2, and R3 minus R2 will lead to subtractions minus 0, minus 1, minus 1, minus 0, and this will give me 1, 0, 2, 1, 0, 1, 1, 0, 0, 0, 0, 1, and the leading non-zero element in each row will be the pivot element. So this is pivot element, this is pivot element, and this is pivot element. And because there are 3 pivot elements, the rank of this matrix will be 3, and that will imply that number of linearly independent vectors is also 3. And the columns containing pivot elements are called pivot columns, and the pivot columns are the linearly independent columns of the matrix, and the vectors corresponding to the pivot columns are linearly independent vectors. So here I can say that vectors v1, v2 and v4 are the linearly independent vectors.